Hello, Leiden geometry students. Today we're going to talk about the triangle angle sum theorem. This idea is a very simple idea that can lead to some problems that have a little bit of algebra in them, but the idea behind all these problems is very, very simple. And that idea is that I can take a triangle, absolutely any triangle in the universe. There's nothing special about this one. Here I've got the corners numbered and colored so you can see them. I'm going to tear the corners of this triangle off. All three angles are going to be torn off here. I'm going to take these three angles and put them together like this. And if you put them together, no matter how you put them together, the three angles are going to make a straight line. Those three angles from the triangle will make a straight line, and it may not be perfect because I tore it kind of funny, but the three angles of a triangle are going to make a straight line. It doesn't matter how you arrange them. If I take those three and scramble them and put them a different way, they're still going to make a straight line. And that's the idea behind the triangle angle sum theorem. Basically, the angles of a triangle always add to 180 degrees, a straight line. The reason for this is based on the stuff that we've been doing in class recently. This picture, where I have two lines cut by a transversal, and the lines have to be parallel. Now, if the lines are parallel, then we know automatically that these two angles have to be congruent because they're alternate interior angles with a parallel line. And we just had a rule that said when the lines are parallel, alternate interior angles are congruent. Well, I can make a triangle by just drawing in a different transversal, like this one. And again, in this case, these two angles will be congruent by the alternate interior angle theorem as well. Now, if we look at the ones up here on top, this red one, this blue one, and this one in the middle, which I'm going to make green, these three angles make a straight line, so they have to add to 180. But this red angle here is the same as this angle down here by alternate interior angle theorem. And the blue one up here would be the same as this blue one down here. So in the previous problem, the red plus the green plus the blue add up to 180. So in this picture, the red plus the green plus the blue have to add up to 180. No matter what the triangle is, the angles add to 180. It doesn't have to be a special triangle like that, and we don't even have to create it that way. If we have a triangle, we could do the same thing. You just pick one of the sides. It doesn't matter which one. I'm going to pick this one on the bottom left, and I'm going to extend it into a line. And then I'm going to go to the far side of the triangle and draw a parallel line through this vertex of the triangle. And by doing that, I can recreate the same picture. So if none of that makes sense to you, if you had trouble remembering that, no big deal. Here's the rule that you got to remember. The measures of the angles in a triangle always add to 180 degrees. This rule will come up over and over again all year. It's one that you will have to commit to memory if you don't already know it. The angles in a triangle always, their measures always add to 180 degrees. And the reason why this will continue to come up is all our other shapes are based on what we know about triangles. So even when we're talking about like an octagon, all the rules that we have for an octagon will be based on how many triangles fit inside it. And so we have to remember our rules for triangles. For example, this first problem. These three angles, we know two of them, but not the third one. We know that they have to add to 180 degrees. So we can write an equation. 65 plus 57 plus x is equal to 180. And then simply solve for x as an old algebra problem. Combine our like terms and subtract 122 from both sides, and we'll get 58 for our missing angle. Same thing in the second problem. These three angles add to 180. Now you're only given one angle measure, but this little square right here in the corner tells you that this is a right angle, so this one's 90. So we could write an equation. 40 plus 90 plus x is equal to 180. And then again, simply combine like terms and solve for x. We'll have 130 plus x is 180, and then subtract 130 from both sides, and we'll get x is equal to 50. The third problem, take a moment and try to find the missing angle. And it's going to be 45. Now, many of you have already found a shortcut by doing this and say, hey, I don't have to write out this equation. I just take out my calculator and do 180 minus 50 minus 85, and it tells me that missing angle. And yes, that absolutely does work for these problems. When our problems get more complicated in just a few moments, that system won't work. But for these easy ones, if you know two of the angles, just subtract them both from 180, and whatever's left has to be the third angle. Here are some examples of some slightly harder problems. They're still not that tough. But that system, that shortcut I just mentioned, won't work. You can't simply subtract these from 180. In the case for these three problems, you will need to have an equation. But the equation's simple. It's still the same thing. The angles are going to add to 180. So in this problem, I can say x plus 2x plus 3x is equal to 180. So we create our equation, and then simply combine like terms and solve for x. We'll have 6x is equal to 180, and divide by 6. We will have x is 30. Second problem, same idea. These three angles add to 180. Remember that this one counts as 90. So first come up with an equation. And the equation is just these three angles. If I add them together, we get 180. Combine like terms and solve for x. We'll have 10x plus 80 is 180. Then subtract 80 from both sides and divide by 10. We will get x is equal to 10. The last problem. Take a second, try to create the equation. Alright, our equation, the three angles add up to 180. It doesn't matter what order you put them in. 48 plus 11x minus 5 plus 9x minus 3 is equal to 180. But then you combine your like terms, and no matter what order you wrote them in, you'll end up at this step. 40 plus 20x is 180. Then we subtract 40 from both sides and divide by 20. And we'll have x is equal to 7. Now these problems can have a follow-up that's actually fairly important. Instead of just asking to solve for x, which we've done in all these, I could ask you, what are these angle measures? Well, then you just take the value for x and plug it back in. Take 30, put it in for x here, put it in for x here, and put it in for x here. And what would these three angles be? Well, x is just 30, 2x is going to be 60, and 3x is going to be 90. And we could do that for any of these problems. Just take the value for x and plug them back into the equations to find the measures of the angles. This problem isn't any harder. It's the same kind of thing, but it's a special problem. This is a triangle where all three angles have the same measure. The angles are equal. We call it equiangular, literally equal angles. We solve this the same way, but anytime we have a triangle where the angles are all equal, we'll always get the same number for the measures of those angles. You set up an equation to solve for x. In this case, that equation will be x plus x plus x is equal to 180. Combine like terms and solve. If 3x is equal to 180, and then simply divide it by 3, and we'll get x is 60. Whenever we have this triangle where all the angles are the same, what we call equiangular, the angles are always going to be 60. This particular triangle pops up over and over again over the course of the semester and year. Sometimes we take the rules we just talked about for triangles and mix it with other rules that we've seen before. In this example, we'll be talking also about vertical angles and supplementary angles. For example, we're trying to find this angle up here, and the way we're going to figure out this angle is by figuring out this one, and the way we figure out this one is going to be to figure out this one. So we're going to have to jump around the triangle. For the next few problems, there isn't a set way to do the problems. You just have to look for information you know. You have to decide, do we have enough to figure out a missing angle inside the triangle, or can we find a set of vertical angles or a set of supplementary angles? In this case, you want to start with these angles. These angles are vertical angles, and therefore the measure of the missing one will have to be 35. These angles have to be the same. That's a rule for vertical angles. Now, we know two of the angles inside, the measures of two of the angles inside a triangle. We can find the third one by simply subtracting those from 180. 180 minus 100, 30, and 35. And what we'll be left with for this missing angle is going to be 45. So now we've got these angles inside the triangle. What we're really trying to find is this angle up here. So we have to remember that these two angles here and here are making a straight line, and therefore they'll add to 180. So to find the missing angle, we will just do 180 minus the 45 to find that missing one. When you do that, we'll get 135. And you might be thinking, oh, that number sounds familiar. I think I just saw that. And you did. There's a special shortcut when we talk about these angles outside the triangle. It's called an exterior angle. And in a triangle, this exterior angle is equal to the two angles that aren't next to it. We call it the remote or far away, the remote exterior angle. This 135 has to be equal to this 100 plus this 35. It's a shortcut that always works, though people tend to forget about it. All right, so we can try that in this problem as well. So in this problem on the left, we know one angle inside the triangle, but we can find this one because these two are making a straight line. So take a second and find this angle first. Well, these two are making a straight line, so they add to 180. 180 minus 155 is going to be 25. Now, these three angles inside the triangle have to add to 180. So we can simply take 180 and subtract these two to find that missing angle. And that missing angle is going to turn out to be 95. Now, the shortcut that we just talked about in the last one is these two, the 60 and the unknown one, have to add to 155. So you could jump to this answer by simply doing 155 minus 60, and you go straight to getting 95. For the third one, take a moment and see if you can get to the measure of this angle. There's a couple different ways to do it. The long way is to find this angle first. It's the third angle in the triangle. We know this one's 20 and this one's 30, so we simply subtract those from 180 and we can find this angle. It's going to be 130. Then if I want to know the one next to it over here, well, the 130 and this missing angle make a straight line, so they have to add to 180. So this missing angle would be 50. You could have jumped straight to the answer for this one, the 50, by simply adding the 30 and the 20, the two interior angles that are far away from that exterior angle.